Hey GameTank devs, this is Dan. I thought I should make a video to explain this paddle input feature that I've been working on for the GameTank. I'll start by explaining what you're seeing on the screen here. This is the GameTank emulator built for WebAssembly and deployed on the web. Or actually, this is probably playing served locally on my machine, but it'll be the same. I do have a web link down below that I'll post, so you can check it out. But what I've done here is I've added the paddle feature to a game I'm working on, which is built in the GameTank SDK, which is the C SDK. I built the ROM file, and then I also added paddle emulation to the emulator and tweaked the HTML so that it picks up touch interface, and plan to show you how I did that so that you could do it for yourself. And the cool thing is you won't need to build or purchase a physical paddle controller, which is also something I'm developing. I guess I forgot to mention that at the beginning, but I started this whole project designing and building a physical paddle, and then it led to all this other stuff. Anyway, I thought it'd be really great to get people interested in the purely software and emulated side of things, because then you don't have to buy a paddle or build one. So let's get into it. So we're going to start on GameTankEmulator underscore paddle feature repo, which is a fork of Clyde's repo. And I'm going to go ahead and click on the releases and download. I'm downloading the macOS pre-compiled emulator and a pre-compiled ROM. So you can just see, test it out really quickly. And I'm going to go ahead and unzip the emulator. Now, since I'm on the Mac, we got to do this weird thing. I'll include the command below if you need it, but you need to cd into that directory and type xattr-cr and GameTankEmulator to bypass the weird security glitch. And there it goes, it runs, and then you can do open ROM and open up the ROM you downloaded. And there it is. And it should, let's see here, you want to hit escape, or yeah, to bring up the menu, go to settings and enable paddle mode. And now you hit Z, which is the A button. And then I'm hitting enter to start the game. And I'm just using the mouse, as you can see, and playing the game. So hopefully you're interested by now and you're ready to write some code, or at least download the boilerplate code. So I'm on my fork of the GameTank SDK, and that's where it is. And then we're going to go to my source tree, so you can look at that's my GameTank SDK repo. I'm in the demo paddle test branch, and let's go into Visual Studio Code. So now we're gonna open up main.c in my GameTank SDK, and down, 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 there it is. And then we're gonna look at all the contents. We've got GameTank H, draw queue, we got paddleInput, which is gonna replace input.h, and we're gonna have a Boolean for using paddle, so we could toggle back and forth. We got our player position and a color variable. So basically, we're going to toggle with the A button um, between using paddle or not using paddle. And every time we toggle, we're going to center the player position. And then we're going to, if we are using the paddle, we're using get paddle rotation, which we'll take a look at in a minute. And we are bitwise shifting it so that we're using a number from 0 to 127, which is in screen space. Here we have D-pad movement, which adds and subtracts the player position. And then there we were correcting the player positioning in case it goes off the screen. And that's it. There's just this one function there inside of that whole loop that's doing the new stuff. All right, so now we're looking into paddleinput.h. Now this is going to replace input.h because we needed to add these new input masks. And basically the difference is that we have up and down are only being read on the high side, the high read, the second read, and then that frees up the first two reads of the same, pretty much on the same wire that goes to the gamepad. Anyway, it frees up 2 more bits. And now we have this new update paddle inputs and get paddle rotation. Get paddle rotation is new, but update paddle inputs is what you're going to use in place of update inputs, because it has a new updated input mask paddle all keys, or input mask all keys. And then this get paddle rotation, what it does is it lines up all the bits into one 8-bit number, and then it inverts it because we're using an ADC and I didn't want to add inverter chips to my paddle. So now we're going to run. Now we're going to we're going to run make clean to erase any previous stuff that's left over, and then we're going to do a make import and then make emulate, which it pulls up the emulator that was available from a repo, a nearby repo. But yeah, there is the paddle emulation. And now what I did in the game, if you recall, is I'm going to press A and the box will change color. But first I'm going to toggle it off. I'm going to press A and now use the gamepad buttons, which are the left and right buttons. So this is just to show that you can have a game that you've already written that uses all the gamepad buttons and then sort of add paddle support to it if you want. Okay, so now we're going to build the emulator. Let's have a look at the code. So we're back at GitHub and we're going back into VS Code and start in gte.cpp and search for paddle. First thing we find is paddle emulation enabled Boolean. See how it's implemented in the WASM build, and also how the checkbox gets added in the app. And then this is where it is in the main loop. It'll take the window size and the mouse state and send that off to update paddle from mouse. We're going to go to the header file. See the 2 new functions and all of the all of the new input masks. And then let's have a look at the implementation. So there's two functions. One is what updates the mouse position. Basically, that converts it to a number between 0 and 255. Then it sends it to set paddle bits direct, which compiles all the bits into a byte, or it adds it to, I think it's 16 bits byte that combines all of the bits, and it puts it in set held buttons. And that's how that works. So we could probably build. So what we're going to do is make clean, wipe out anything that we had before, and then we're just going to make OS equals WASM and embed the ROM file. Oh wait, we're not doing WASM. We're just going to make the Mac emulator. My environment is set up so that I don't have to say OS equals Mac or Darwin or whatever. I think everyone's environment is probably set up slightly differently. And I also probably edited my make file. So just a little bit of heads up. I'm guessing that anyone who's watching this hopefully has experience with setting up these environments and using these build tools. I'm trying to focus on the differences that I made, the changes I made to implement the paddle. Okay, and let's have a look. Oh yeah, we're just gonna run it with our test ROM. And it'll look just like before. Got the same toggle. I'm moving the mouse very quickly, trying to emphasize that it's pretty low latency. And that's it. All right, so now we're gonna do the WASM build. And a lot of it is the same. I'm gonna quickly look at some of the C++ code again, but the gist of it is, and you can, I don't know, slow it down and look at the code. But the gist of it is that it still winds up in, this update. It doesn't use the update mouse anymore. It uses set paddle direct. So that's what we're seeing right here. And it's actually using the set paddle value, um, uh, which gets called through the HTML JavaScript side of things. So let's have a look at the HTML file. So you want to look in web, down, okay, shell.html. And now we're going to find these definitions for the buttons. These are buttons that I added so that when you turn on paddle mode, because of the strange nature of the way the mouse position gets captured, it seemed like I couldn't use the grid-based buttons that would normally work for the D-pad. So I dim the background and add an A and a start button since my game doesn't need much else. So it's pretty bare bones. So that's why we're using those fab buttons. And then we should finally get to set paddle buttons, which is, so this is toggle paddle mode. Down a little more. Oh, it's called set paddle value. So in the event listeners for mouse move and touch move, they both go to set paddle value, which we were looking at before in the C++ side, which then goes on to call set paddle bits direct or something. But anyway, let's build this. So this environment was took a lot of work to set up. We had to download EMSDK, run a lot of environment stuff. For my particular environment, I had to sort of brute force get rid of all the include paths for to get rid of the max stuff. Here, what you're seeing me do is I'm running the EMSDK environment setup. And now this is how I'm going to make OS equals WASM and then embed the ROM file. If I could remember where it is. Okay. And the really cool thing that I learned is, because I didn't know this until recently, is that you can go into your build directory and run a web server right there using Python. But what I learned is on my Windows machine, I have to run Python -m http.server space 8000. But on my Mac, I have to run Python 3, and then it works. And now I can go to my browser, go to localhost colon 8000, where I guess my browser was already going there. And here we are again. If you stretch out the window on a desktop, you're going to get this landscape mode, which looks totally different. And you just toggle that. You hit Z to press the A button, and then you hit enter, and you're playing. You could go to JavaScript console, and emulate a device. And now you've got touch controls. So I had to toggle that paddle on off thing a couple times because it's not synchronized to the other checkbox toggle, just so you know. Okay, so to wrap up, I hope I've provided enough information to get developers started in playing with the new controller inputs. I'll be on the Discord, which I'll link below, and you can find me as Shimmy in the Discord. And I'll leave you with some footage of the paddle controller prototype in action with original hardware. That's all. Have a nice day.